Okay, so if we've got a rubber ball and it's dropped from a height of 3.2 meters after bouncing off the floor, it bounces magically to its original height. If the impact time with the floor is measured to be 0.04 seconds, what average force did the floor exert on the ball? So the way, and here are your options. So here's the floor, and here's the ball. You drop it from this height of 3.2 meters, so it's going to hit the floor here, and it's going to get an upward force like this. And we're just going to get the average force. Obviously the force, as it interacts with the floor, it starts 0 and then it ramps up to a maximum, and then as it rebounds off it goes back down to 0. But we're just going to, what's the average force on that? And the reason that it goes back up to the same height, they're trying to make it a little bit easier for you, because if you draw before and after picture, like here's the ball, just as it's making contact with the floor, and its velocity, this is down like this, and then when it leaves, if it's going to go back up to its original height, it has to have an identical velocity, but now it's up instead of down. So the magnitude of these guys is the same. Let's figure out what this velocity is. And well, delta y, we know what delta y is, and we want to know what the, I know what to do, I'm sorry. We don't know time, the time it takes to fall, we don't need it, so I'm going to use the fourth kinematic equation. And let's see, v squared, this is what we want. The initial velocity, see v naught is up here, that's going to be 0. So v is going to be equal to the square root of 2. Now, one of the things you're allowed to do is use 10 on multiple choice instead of 9.8. So I'm just going to use 10 meters per second squared. And then delta y is given to be 3.2 meters. So v is equal to the square root of, well, what is that? 2 times 3.2 is what? 6.4? And 10 times 6.4 is 64? So what's the square root of 64? 8. Now that's what they're going to do on the multiple choice. They're going to try to give you numbers where you don't need a calculator, or if you're clever and you can figure it out. So this is going to hit the ground at 8 meters per second. And it's going to leave the ground at 8 meters per second. So let's figure out now, then we have to use the impulse momentum theorem. We say the force times time on the ball is going to be equal to the change in momentum of the ball. And so we can solve for the force, or the average force, if we just take the change in momentum and divide it by the time. And the change in momentum, well, that's the mass of the ball, which is 0.08 kilograms. Now here's where you got to really think hard. Delta B, that's v final minus v initial, right, times the mass. And what is v final? V final is 8 meters per second. That's this velocity. What was v initial? Well, you subtract from it. What was v initial? Oh, it was -8. Right, because going down, this should be -8 right here, right? Because this is plus or minus. So you choose the -8 because it's falling down. And then we're going to divide this by 0.04. And so the force is, well, this is 16, so you got 0.08. And I'm going to leave the times 16 divided by 0.04. Well, what is 0.08 divided by 0.04? 2. 2 times 16 is 32 newtons. So the answer is C. Whoop. There we go. Now, again, this is a multiple choice problem, and I've been working on it for 5 minutes, which is 3.5 minutes too long. But I'm also trying to explain it and write a lot of stuff down and all that. So some of you are really good at doing stuff in your head and figuring stuff out, and that's the multiple choice is your advantage. You know, you're going to be able to fly through that, hopefully. Anyway, so this is it. Any questions? Okay, that is all.